Welcome to Graphing and Simultaneous Equations lesson number 8, solving simultaneous equations via elimination. So in the last lesson, we had a look at how we could solve these or find the solutions to two unknowns in a set of two equations, and we did that using the graphical method. So the point at which these two lines intersect, we said that was the solution or the values of the two unknowns. In this video, we're going to have a look at how we can do or get to this final result of these two numbers, but doing it analytically using a method called elimination. So the learning objectives for this lesson is to solve simultaneous equations via the elimination method, and that's going to be broken down into two parts. So we need to learn how to scale equations by multiplying all terms within the equation and add and subtract equations together. Now jumping into it, consider solving via elimination. Solve via elimination. So using the elimination method, we solve via combining two equations such that they cancel out a term, thus resulting in an equation with only one unknown. So what would that look like? Well, the best way to explain it is simply by demonstration. So consider we have two examples or two equations here, and we want to know the values for x and we want to know the values for y. So what I can do is I can get my pen and I can write out 4 equals 3x plus 7y, and then in orange I can write out -1 equals 3x plus 7, not 7, plus 2y. So notice I've lined up the terms with the same unknowns, and this is where the magic happens. This is where I'm going to do the trick called elimination that will get me the value of an unknown. So what I'm going to do is minus this orange equation from this blue equation. So what we're going to say is 4 minus -1, that's going to be 4 minus -1 is 4 plus 1, which is 5. And then 3x minus 3x, that will be 0x. And then 7y minus 2y, that will be plus 5y. Therefore, we're left with the equation 5 equals 5y, and then we can say y equals 1. So dividing both sides of this equation, so we find that our solution to y is 1. Now if we go back and we substitute this in, so we'll pick 4 equals 3x plus 7y, and then we're going to say let y equal 1. What we find is we can solve the value of x as such. So 7 times 1, because we said let y equal 1, substitute 1 in for y. Now evaluating these expressions, 7 times 1 is 1, taking 7 from both sides of the equation, that yields -3x, and therefore we find x equals -3, dividing both sides. So the solutions to these equations here, so x, and y, the solutions to those are -3, because the x value comes first, and then 1. So this method here is what we call the elimination method. So on the left here, we line all of these values up, then we take one equation away from the other and then solve for the only remaining unknown. But what happens if, so notice in this equation, 3x and 3x, so we've got a common 3x there. What happens if we don't have variables that are the same? So what happens if we've got something like 5x and 2x? Well, what we need to do is we have to do some scaling or factoring of the equation. So consider 3 equals 5x plus 2 and negative 4 equals 2x plus 6y. So we've got 3 equals 5x plus 2y, and then we've got negative 4 equals 2x plus 6y. Well, what I need to do is I need to either make this 5x and this 2x equal the same thing, or I need to make this 2y and this 6y equal the same thing, as in I need them to have the same coefficient so I can cancel them out when I eliminate one of them. So what I can do in this case is I can multiply. In this case, I'll multiply this left equation, or equation 1. I'm going to multiply it by 3. So both sides of the equation, I'm going to multiply it by 3. And the net result from multiplying it by 3 is that this side becomes 9. This will be 15x plus 6y. So notice now I've got a common coefficient in front of the y, the variable y, in both equations. So if I say this one, do that orange. So if I put negative 4 there, then we say 2x plus 6y, and I subtract this orange equation from the black equation, or equation 1, the modified equation 1, or scaled equation 1, from the equation 2. What we find is that we get 9 minus negative 4, or 9 plus 4, is going to be 13. 15x minus 2x is going to be 13x, and then 6y minus 6y is going to be 0y, or it cancels out. And then moving down, we find that we've got 13x equals 13, and dividing both sides of the equation by 13, we are then left with, wrong pen, we're then left with x equals 1. Too easy. Now that we've got our x value, so x equals 1, let's grab our equation back again, and we'll say negative 4 equals 2x plus 6y. Then we're going to say let x equal 1. Then substituting 1 in for x, negative 4, 2, 1 plus 6y. Evaluating these expressions, we've got negative 4 and 2 plus 6y. Then negative 6 equals y. Therefore, we find that y equals negative 6. Thus, the solutions to this equation, so our x and our y is equal to 1 and negative 1. Once again, what a coincidence. Actually, this is wrong. I got this wrong. Should be a 6 there. All right, going back. Going back to this line, we get negative 6 equals 6y, and thus y equals negative 1. Perfect. So now it makes sense. Now let's go down to question 3, third and final question. So we've got 5 equals 3x plus 2y, and then we've got negative 1 or 1 minus 2x equals 6y. So notice that they're in completely different forms. So the first one is 5 equals 3x plus 2y. And then the second one is y minus 2x. 2x equals 6y. So what I need to do is get them both in the same form. Now we've been working in this form in all our solutions so far. So we'll go back to that form. So we'll say 1 equals 2x plus 6y. Now we need to make them such that they are common. So what I'm going to do is I'm going to multiply both of these by 3. So both these sides by 3. And then we'll get a common 6 or coefficient of 6 in front of the y's. And going down, we'll get 15 equals 9x plus 6y. Now let's just say that this equation here is now going to be written in orange. So it will be 1 equals 2x plus 6y. We're going to subtract the 2. So in green, we'll subtract the 2. And 15 minus 1, that's going to be 14. 9x minus 2x, that is going to be 7x. And 6y plus 6 or minus 6y is going to be 0y, which cancels. And then solving for x, we're going to get 7x equals 14. And therefore our x is going to be a value of 2. Now putting it all back together, since x equals 2, we'll go with this form up here and we'll say 1 minus 2x plus 6y, and then we'll say let x equal 2, and that will be 1 equals 2 plus 6y. Solving 1 minus 4 or 1 equals 4 plus 6 if it's going to draw it, 6y, and then negative 3. So taking 4 from both sides, negative 3 equals 6y, and therefore y equals negative 0.5. Therefore, our solutions to this equation, x and y, is going to be x equals 2 and y equals negative 0.5. So, in conclusion, what we set out to seek today, or set out to learn today, was we wanted to learn how to solve simultaneous equations analytically using the elimination method. And we did that via learning firstly how to scale equations and then how to add and subtract equations together. And that showed us how we could do the elimination method. So the end of this lesson, what you should be able to do is you should be able to add and subtract equations together. You should be able to scale equations by multiplying all terms within an equation. And you should be able to solve equations via the elimination method.